Yeah, we can practice some problem, but if you have any specific question, then I can answer that question. Yeah, and we need to also continue our regular class, um, because actually I want to give more time on the review for the final, because the final is cumulative, so it will cover chapter 1 to chapter 11. So I want to give more time on the review for the final. And to do that, we need to actually finish the course materials like maybe 3-4 class before the final. So the final will be in December. I forgot the exact date. So it is on the syllabus. So you can look at the syllabus, or I can just let you know in the next class. Or okay, so to make decision about the hypothesis test, whether we'll be rejecting the hypothesis test or whether we'll be failing to reject the hypothesis test, there are two approaches. One is called the critical value approach, and the other one is p-value approach. So what is the critical value approach? So before doing any hypothesis test, the steps are: first you need to write the hypothesis. Then you need to decide about your alpha. Alpha is the level of significance. You need to determine this one. So usually the level of significance is 1%, 5%, or 10%. Or it could be also 2%, 3%. Yeah. So if alpha is 1%, then it is 0.01. So for one tail test, the critical value for right tail test, so if our alternative is this one, suppose mu greater than mu0, so this is right tail test. So in that case, for z test, the critical value is z alpha. So what is z alpha? Alpha is 0.01. So you will consider this one as probability, 0.01. Then from the table, you will find the value of z. You will find the z score. So that is your z alpha. So that's mean you need to find this one, z 0.01. Okay, so in critical value approach, you need to find the test statistics, z observed, zo, which is x bar minus mu0 divided by sigma over square root of n. Okay, so now we have the critical value and you have the test statistics. So for the right tail test, okay, so for the when alternative is mu greater than mu0, the rejection region will be on the right side. So this is the rejection region, and this is our z score. So for example, let's consider the z score is 1.96, and z observed, let's consider z observed is 2.30. Okay, so now we will compare these two values, the z score and the critical value and the test statistics. So this one is called the test statistic. So you will calculate this one, right? You know how to do it. And this one is the critical value, 1.96. Now we'll compare these two. So this is 1.96. So 2.30 will be somewhere here, right? 2.30 will be somewhere here. So that's mean 2.30 is in the rejection region. So in this case, we will reject the null hypothesis. So that's mean we have sufficient evidence to conclude the alternative. So that's mean at alpha equals to 1%, the data provide sufficient evidence that the mean is greater than mu0. The population mean mu is greater than mu0. So that should be our conclusion when we reject the null. So when we fail to reject the null, So that's when we cannot conclude the alternative. So that's when we do not have sufficient evidence to conclude that the population mean is greater than the value mu0. Yeah, that's the critical value approach. And for the p-value approach, okay, for example, instead of this test statistics, if you have z observed is 1.2 or negative 1.2, whatever it is, then where is 1.2? 1.2 is somewhere here, right? Because this one is 1.96. So 1.2 is somewhere here. So that's mean the test statistics is outside the rejection region. So in that case, we fail to reject the null. And this is also similar to left tail test. Okay, so for the left tail test, the alternative is mu less than mu0. So that should be the rejection region. And in this case, the critical value is negative z alpha. So first you will determine the alpha value. Alpha could be 1%, 2%, 5%, or 10%. Then you will calculate the negative z alpha. Then you calculate the, for example, let's consider this is negative 1.64. And you will calculate the test statistics. If test statistics is, and the formula is x bar minus mu0 sigma over square root of n when sigma is known. But when sigma is unknown, you will use t-test. Then it will be t observed. And instead of sigma, you will be using s, the sample standard deviation. Anyway, so let's consider this value is negative 0.34. So this is our test statistics. So where is negative 0.34 located? It should be somewhere here, right? So that's mean this value, the test statistic, is outside the rejection region. So in this case, we fail to reject the null. So this is called the critical value approach. And our conclusion will be, we do not have sufficient evidence, or the data doesn't provide sufficient evidence to conclude that the population mean is less than mu0. Okay, so what is the p-value approach? So in p-value approach, instead of comparing the critical value, so we'll calculate the p-value. So how do we calculate the p-value? So for example, if our test is right tail test, then this is z alpha, this is our rejection region. Okay, so let's consider this is 1.96. Now we'll calculate the z observed. Okay. Forget about the critical value. So let's consider alpha is 5%. So that's mean this area is 0.05. Okay, so now we'll calculate the test statistics using this formula x bar minus mu0 sigma over square root of n. Let's consider this value is maybe 1.12. Okay, let's consider this value is 1.12. Okay, so 1.12 will be somewhere here. So what is the p-value in this case? Since this is right tail test, the p-value will be probability of z greater than z0 for right tail test. For left tail test, it will be opposite. It will be z less than z0. Okay, so probability of z greater than z0. So that's mean probability of z greater than 1.12. So now from the z table, you will find this probability. And for sure, this probability will be greater than 0.05, right? Because probability of z greater than 1.12, so that's been this area, this total area. That area will be larger than the area of the rejection region. So that's mean the p-value will be greater than 0.05. So in this case, the p-value, if you calculate p-value, this will be greater than alpha. And you can see that the test statistics is outside the rejection region. So that's mean we fail to reject null. We fail to FTR. FTR means fail to reject. Fail to reject null. So that's mean in case of p-value, if p-value is greater than alpha, we fail to reject null. And if p-value is less than alpha, so that's mean, for example, if it is right tail test and our test is this is z alpha, and if our test statistics is somewhere here, if this is our z observed, then the p-value will be this area. So which is less than the area of the rejection region, right? So that's mean when p-value is, and in this case we reject the null. So that's mean when p-value is less than alpha, we reject the null hypothesis. And if p-value is greater than alpha, we fail to reject the null hypothesis. Okay, so your question also had some other parts. If a value is rejected, not because of the evidence support. Okay, so when you reject, that's mean the data provides sufficient evidence to conclude the alternative. Alternative means here mu greater than mu zero. So that's mean the data provide sufficient evidence to conclude that the population mean mu is greater than mu zero. And when we fail to reject null, so that's mean the data doesn't provide sufficient evidence to conclude that the population mean mu is greater than mu zero in this case. So is that answer your question? Okay, so what time does the quiz open? Yes, I can explain how we get the z observed, z0. Okay, so let me go over one example, previous example. Okay, so let's consider this example. So the recommended RDA of iron for adults is 18 milligram per day. And here the sample size is 45. And the population standard deviation is 4.7. And we want to test, so at 5% significance level, so the level of significance is 5%. So we want to see whether the data suggests that the adult females are on average getting less than the RDA of 18 milligram of iron. So we want to see whether the female are getting less than 18 milligram of iron. So that's mean we want to test whether mu is, the population mean is less than 18. So our null hypothesis is mu equals to 18 and alternative is mu less than 18. So this is the step one. You need to write the hypothesis. Okay, then you need to determine the alpha, the level of significance. So what is the level of significance? Here it is 5%, right? So the level of significance is 5%. So alpha is 5%, which is 0.05. Okay, so good questions. How do we calculate z observed? So z observed is equal x bar minus the hypothesized value mu zero. Mu zero means this one, divided by sigma over square root of n. So in this case, sigma is known. We know that sigma is 4.7. So that's why we use sigma over square root of n. So this is the z observed or z0. This is called the test statistic. So x bar minus mu 0. So what is x bar? X bar is the sample mean. So what is the sample mean here? So 45 random sample, and the sample mean is, it is given here, as assume that the population standard deviation is 4.7. Yeah, it is actually not that x bar is 14 point, here it is given x bar is 14.77. So that's been 14.77 minus mu 0. Mu 0 is 18 divided by standard deviation, which is 4.7, divided by square root of n. Square root of n means n is 45, the sample size. And if you simplify this one, then it will be negative 5.43. So this is our z observed. So is that answer your question? Okay. Yes. The next step is good question. So where is z alpha? Yeah. So the next question is, how do we determine z alpha? How do we get z alpha? So here the alpha is 0.05, right? 5%. The alpha is 0.05, 5%. So in this case, the test is left tail test because our alternative is mu less than 18. So this is less than. So that's mean this is left tail test. So the critical value will be then, this is left tail test. So the critical value will be negative z alpha. And here alpha is 5%. So negative z alpha is, so you will find z alpha from the z table. So if you look at the z table, then you will see that for 0.05, when the area is 0.05, the z score is, the 0.05 area is between the z score negative 1.64 and negative 1.65. So if you look at the z table, then you will see that 0.05 area is between negative 1.64 and negative 1.65. So if you take the average of these two numbers, it will be negative 1.645. So the z alpha is here negative 1.645. Okay, so now we have z alpha and we also have z observed, z0. Z0 is negative 5.43. So where is negative 5.43 located? So this is located somewhere here. So that's mean negative 5.43 is located in the rejection region. So we reject the null hypothesis in this case. That's why we rejected the null hypothesis. And our conclusion will be, in this case, the data provide sufficient evidence that the population mean mu is less than 18. Or you can say that our data provides sufficient evidence that the adult female are getting less than 18 milligram of iron. Do you have any question? Any question or? Okay, thank you. So yeah, the p-value. So how do we get the p-value? So we know that z observed. Very good question. Thank you. Okay, so let's go back to the same problem. So here. Yeah, so now the question is, how do we, so here we made our decision using the critical value approach. Okay, now if you do not want to use the critical value approach, then you can calculate the p-value. So now the question is, how do we get the p-value? So to calculate the p-value, so you know the test statistics, right? So which is negative 5.43. So we know that Z observed is negative 5.43. So this is our test statistics. And you also know that tail of the test. So this is mu less than 18. So this is left tail test, right? So the p-value will be in this case probability of Z less than Z0. So that's mean probability of Z less than negative 5.43. So now you need to look at the Z table. So if you look at the Z table, the probability will be then, okay, so here the probability is not given. So you need to actually find the probability. Negative 5.43, this probability will be actually less than 0.01, I think. Yeah. So I'm not going to show you how to find the p-value from the Z table, because I think you already know how to find the p-value from the Z table. In the Z table, you have to just look at this number for the z-score, negative 5.43, and you will directly get the value of for the probability, and that will be less than 0.01, and which is less than the alpha value. So here the p-value, so if you find the p-value, you will see that this p-value is less than the alpha value. So that's mean you will be rejecting the null hypothesis. Okay, so any other question? Yeah, alpha value is given. Yeah, that's correct. Alpha value is given and it was 5%. So that's why it is 0.05. Yeah, very good question. You're welcome. Okay, so in the last class, we were discussing about the one hypothesis test for one population mean when sigma is unknown. So that's mean this value is not given. So we will be using the sample standard deviation instead of sigma. We'll be using S instead of sigma. So in this case, the test will be t-test because it follows the test statistics follows t-distribution. So that's why it will be t-test. Okay, so the idea is same. The only difference is here to find that probability or critical value, we'll be using the t-table instead of z-table. Okay, so we'll go over some example. A sample mean, sample size, and sample standard deviation are provided below. So we have the sample mean, sample size, and sample standard deviation. So all the values came from sample, not from the population. So that's mean we have S, we have X bar, and the sample size is 32. So here we can consider the sample size is large sample size. So that's when we can use t-test. And here alpha is given, which is 1%. The level of significance is 1%. Okay, the first thing first, you need to write the hypothesis. So which is mu equal 25, and the alternative is mu less than 25. So this is for sure left tail test, right? Because mu is less than 25. Okay, the next step is determine the alpha value, which is 1%. So that's mean 0.01. Okay, step 3 is calculate the test statistics. So here the test statistics will be t observed or t0, which is x bar minus mu 0 divided by s over square root of n. In z-test, it was sigma over square root of n. Now it is s over square root of n. So whenever you have S, you will be using t-test if the sample size is large or the population distribution is normal distribution. But if you have sigma, then you will be using the z-test. Okay, so what is X bar? X bar is 24 minus mu0 is 25, the hypothesis value. The sample standard deviation is 5. S is 5, square root of 32. If you simplify this one, then it will be negative 1.13. So this is our test statistic. Okay. So now we have the test statistics. So if you want to use the critical value approach, you need to find the critical value. So then step 4, find the critical value. So you will be, sorry, this is not Z alpha. You will find the T alpha value. So now the question is it T alpha or negative T alpha? It will be negative T alpha. Why? Because the test is left tail test. So the critical value will be negative T alpha. Okay. Now, one thing you need to remember, to find the probability or the T value from the T table, you need to know the degrees of freedom, DF, which is called the degrees of freedom, which is n minus 1. In this case, the degrees of freedom is 32 because the sample size is 32. 32 minus 1, so degrees of freedom is 31. Okay, so now we'll find the critical value. So how do we find the critical value? Critical value is negative T alpha, and this is the rejection region. So here alpha is 1%, alpha is 0.01. So let's go back to the T table. So we know the alpha value. So that's mean we know the probability, which is 0.01. So where is T is 0.01? This is T 0.01. Okay, so what is the degrees of freedom? The degrees of freedom is 31, right? So this column represents the degrees of freedom. Also, this column represents the degrees of freedom. They are same. So look at 31. So this is 31. So the value is 2.453. So T alpha is 2.453, but our critical value is negative T alpha. So that's mean it will be negative 2.453. Okay, then step 5 is we'll make our decision based comparing the critical value and the test statistic. So what is the test statistics? Which is negative 1.13. The test statistics is negative 1. T observed is negative 1.13. So where is negative 1.13 located? It will be somewhere here, right? Because this value is negative 2.453. So negative 1.13 will be on the left, on the right side of this value, right? Because this value is higher than this one. So it is outside the rejection region. So do we reject null or fail to reject null in this case? So what do you think? Should we reject null or fail to reject null? Yes, that's correct. Thank you. So we fail to reject null. FTRH0. FTR means fail to reject. So we fail to reject null. So what was the null? The null was mu is less than 25, right? So the null was mu is less than 25. Since we failed to reject null, so that's mean the data at alpha equals to 1%, level of significance 1%, the data doesn't provide sufficient evidence to conclude that the population mean is less than 25. So that should be the conclusion or interpretation. Okay, so do you have any question? So the idea is same as the hypothesis test or as the Z test. The only difference is Now we are using T table instead of Z table, but the idea is exactly the same. So let's go over some more example. A sample mean and sample size, sample standard deviation. So this is also the similar hypothesis test. The only difference is here we'll be using the p-value instead of critical value approach. Okay, so first thing you need to write the hypothesis. So the hypotheses are already there. You just need to write down them. That's it. Then you will determine the alpha value. So alpha is 10%, which is 0.10. Then you will find the test statistics T0, which is x bar minus mu 0 s over square root of n. The mu 0 is 22. X bar is 21. Sample standard deviation is 6. N is 15. Okay, the test statistics is, after simplifying this, it will be negative 0.65. Okay, so now we will find the p-value. Instead of comparing the test statistics and the critical value, so you will find the p-value. So you do not need to find the critical value in this case, because we are not going to use the critical value approach. We are going to use the p-value approach. So you need to find the probability. What will be the p-value? So since this is less than, it will be t less than t0. So that's mean probability of t less than negative 0.65. Okay, so we need to find the p-value. So what is the degrees of, to find the p-value or to find the t-value, you need to know the degrees of freedom. So what is the degrees of freedom in this case? What is df? Anyone? This is n minus 1. Okay, so no, it is not 21. 22 is the hypothesis value, mu 0. Yeah, it should be, yeah, that's correct. It should be 14. Yeah, that's correct. Yeah, it should be 14. 15 minus 1. Yes. So that is the degrees of freedom. So where is 14? So this is 14. Okay, so the test statistics is negative 0.65. We do not have negative 0.65 here, right? Okay. The thing is that here we do not have negative 0.65, but you can also look at the positive value. You will get the same probability actually. Okay, since the t distribution is also symmetric. Okay, so if you look at negative 0.65, 0.65 is also not here. Okay, but what we can do here, look at this one, 2.9. The p-value is 0.005. This is the probability, 0.005. For 2.64, it will be 0.01. For 2.145, it will be 0.025. It will be 0.05. And for this one, it will be 0.01. Okay. Now, you can see when t is decreasing, the p-value is increasing, right? Probability is increasing, 0.005, 0.01, 0.025, 0.05, 0.10. So this is 0.65. So that's mean this is smaller than 1.35. So that's mean the probability will be greater than 0.10, right? So that's mean the p-value will be greater than 0.10. So that's mean the p-value, and this is actually alpha. The p-value is, even though you do not know the exact p-value from here, but you know that the p-value is greater than alpha. So that's mean you can make your decision. Or if you want to get the exact p-value, okay, so where did you get negative 0.65? Okay, so this is actually test statistic. T observed, x bar minus mu 0 divided by s over square root of n. So you plug in all the number here. So x bar is 21 minus 22, and this is, yeah, very good question. This is sigma over square root of 15. So if you simplify this one, it will be negative 0.65. Yeah. So that is your test statistic, t observed. And the p-value is probability of t less than t0 in this case, because our test is left tail test, mu less than. If mu is greater than, then it will be mu greater, t greater than. Yeah, so yeah, it is FTR. We fail to reject the null hypothesis because the p-value is greater than alpha. Okay, if you want to get the exact p-value, you can, this is actually partial t-table. This is not the complete t-table. So you can look at the complete t-table, or you can also use the online calculator. So you can just do online t-test calculator. Okay, so let me share this screen. So can you see the screen p-value from t-score calculator? Okay, that's great. So you can use this online calculator, p-value from t-score calculator. So here you can just write the t-score. So in our case, the t-score was negative 0.645 or something. Let me check. Yeah, 65. Negative 0.65, and degrees of freedom was 14. And the level of significance was this one, 0.10. So this is one tail, right? Yeah, this is left tail test. Now you'll do calculate. And here you can see the p-value is 0.263108. So that's mean the p-value is greater than alpha 0.10. This is the exact p-value. So if you want to get the exact p-value, you can use this calculator or you can use the complete t-table, not the partial one. Okay. So the p-value is 0.263. So let me share. Oops. Okay, so we found the p-value is 0.263, I think. So which is greater than alpha. So that's mean we failed to reject the null. So, but you can use the partial table as well, because we just need to know this one, whether the p-value is greater than alpha or less than alpha. So in this case, you do not need the exact p-value. So as long as you have, you know, whether p-value is less than alpha or greater than alpha, that would be fine. But if you want to get the exact p-value, you can use the calculator or you can use the complete t-table. Okay, so we failed to reject null in this case. How do we know if it is one or two tail test? Yeah, that's a very good question. So you will always write the null hypothesis and alternative hypothesis. To determine the tail of the test, you will look at the alternative hypothesis. So there are actually two types of tests. So sorry, one tail test and two tail test. And one tail test has also two types, upper tail and lower tail, or you can say left tail or right tail. So you will have three type of alternative. Okay, so let me write it clearly. So you can have this alternative, mu less than mu 0. You can have this alternative, mu greater than mu 0. You can have this alternative, mu is different from mu 0. So if it is mu less than mu 0, this is called left tail. This is one tail. If it is mu greater than, this is right tail. And if you have mu is different from mu 0, this is called two-tail test. So this is two-tail test. Okay. So do you have any other question? Okay, you're welcome. So let me go over one more example, and after that, you will start your quiz. So a sample mean, sample size is given, and sample standard deviation is given. So this is also t-test. So in this case, this is right tail test, right? Because alternative is mu greater than 25, and alpha is 1%. The level of significance is 1%. So here alpha is 1%, which is 0.01. And test statistics t observed is x bar minus mu 0 is over square root of n. So x bar is 27 minus mu 0 is 25, and s is 9 over square root of 24. So if you simplify this one, then it will be 1.09. Okay, so now we need to find the critical value. So the critical value is t alpha, because this is right tail test. So the rejection region will be this one. This is t alpha. This is t 0.01. The degrees of freedom. So what is the degrees of freedom here? N minus 1, which is 24 minus 1. So degrees of freedom is 23. So 23 is here. And alpha is 0.01. So where is 0.01? This is t 0.01. So the critical value is 2.50. The alpha is 2.50. Okay, so now we have the test statistics, we have the critical value. So do we reject the null or fail to reject the null in this case? So what do you think? Okay, so I'm getting actually different responses. Yeah, so some of you are saying fail to reject, and some of you are saying reject the null. So that's mean you still have confusion, right? Okay, so let me explain it. So this is 2.5. T alpha is 2.5, and this is the rejection region. The critical value is 2.5. So now look at the t observed, the test statistics. So where the test statistics is located on the normal curve. So is it in the rejection region or outside the rejection region? In the rejection region means somewhere here, and outside the rejection region means somewhere here. So what do you think? This is outside, right? This is clearly outside the rejection region, because 1.09 will be somewhere here. 1.09 will be somewhere here. So that means 1.09, the test statistic is outside the rejection region. So we fail to reject the null. So it's always better to draw the normal curve and locate the critical value and the test statistics and see where they are located. If the test statistics is located inside the rejection region, you will reject the null. If it is outside the rejection region, you will fail to reject the null. Okay, so yeah, how do we know whether it is right tail or left tail? Because you will always look at that to determine the tail. You will always look at the alternative hypothesis. Yeah, I already mentioned several times. You will always look at, very good question. You will always look at the alternative hypothesis. If it is greater than, this is right tail test. If this is less than, it is left tail test. If it is not equal, then it is two-tailed test. Okay, I think you have also some other question. Let me answer all of your question. So how do we know the p-value is less than the alpha value without knowing its value? Oh, okay. So for the t-table, you can just look at the pattern. So you can see here, when the t is decreasing, so t goes from right to left, what happens to the p-value? So it increases, right? 0.005, 0.01, 0.025, 0.05, 0.1 when t decreases. So that's mean if you have the smaller t value, so this is 1 point, so for example, this is 1.33. So if you have t 0.5 or 0.52, which is on the left side of this value, right? So that's mean the p-value is be greater than 0.10. Or similarly, if you have t which is, for example, if you have t 3.1 and it is a freedom 23, so this is greater than 2.80, right? And we can see that when t is increasing, the p-value is decreasing. So that's mean for t 0.31, the p-value will be less than 0.005. Yeah, without knowing the exact p-value, you can just see whether p-value is less than this value, or whether p-value is between this value, or whether p-value is greater than this value. You can determine this from the partial t-table, but you can also get the exact p-value from the complete t-table, or you can just use the calculator to find the exact p-value. Okay, so I think you have some other questions. Let me. Oh, it's already 11:50. So you can start your quiz now. So you'll have total 30 minutes to complete the quiz. Yeah. If you want, you are free to leave the meeting. But if you want to stay, that's fine. I'll be here. If you have any other question, you can ask me. Okay. Thank you. Best of luck. You are welcome. Okay, so how do you know when we accept and reject? Yeah, for p-value, if p-value is less than alpha, you will reject. If p-value is greater than alpha, you fail to reject. Okay, so the error question, there are two type of error, type 1 error and type 2 error. So type 1 error means you will reject null when in fact null is true. And type 2, fail to reject null You're welcome.